everything they've done here today and getting this event up and running. We really appreciate it, and I think it's a great idea, all of these tasks that are ongoing throughout the year. Obviously, we're very privileged to be shortlisted for this award. We're delighted to be here, and I've no doubt in my mind that you're all here or you will be here to enjoy this presentation. So I think with that, I'll let Matthew introduce himself and give an overview of the project.
Thanks, Marcus. My name is Matthew Gallagher, and I'm acting as the project manager for Stewart's on the job. Give you a bit of information about it. It's two projects as such meshed together. We have a refurbishment, we have a refurbishment of an existing Georgian building. Am I in the wrong? There we are. We have a refurbishment of an existing Georgian building, which you can see there in the photograph. And in the garden, which is 9 meters wide and 48 meters long, we're building a new extension. So the big restraining factor for us is the size of the site. For practicalities, we've actually had to use our next door neighbour, who's SCSI. We've had to use their garden as a laydown area for compounds and for laydown areas. So we've used BIM for our coordination on site, a lot for temporary works, as well as within the building itself for services. So for that purpose, BIM has been very useful, but we'll discuss that a bit more as we progress. So here you can see this is actually, we are using BIM primarily, almost entirely, for the extension rather than for the existing building. As it's existing, we're doing that normal 2D design, and we're using the BIM model for the extension works. Here you can actually see the rendered model of what the extension works will be. It's Oaklux glazing with a copper mesh inside to give a very contemporary look. Mirrored with that, we have a rendered washed finish to brickwork, which will then hopefully be very, sympathetic to the existing Georgian building. So, as such, that's kind of an overview of the building itself. I'll now hand over to Marcus. He'll explain, I suppose, how we're integrating BIM into it.
Thanks very much. I'm Marcus O'Byrne. I'm the BIM manager within Stewart, but more importantly on this project, I'm the project information delivery manager. And I'm just going to go through some of the driving factors for us and adopting BIM on this project, some of the obstacles that we encountered, and in turn how we overcame those obstacles. Finally, then I'll run through the benefits that we've realised to date. Just to note, this is an ongoing project, so bear that in mind as we progress through the presentation. One of the main driving factors for us was that there was no contractual obligation for us to bring BIM to the table for this project. So it was an exercise for ourselves to see if we could achieve or realise some of those benefits that are always being thrown at us within the construction industry. We obviously, for us, that meant taking on initial larger workloads. So we did end up having to draft the EIR ourselves. We had to make sure that all the subcontractors on site were compliant with the software that we were going to be using or had intended to use. And another driving factor for us in this was just to aid the buildability of the entire project. As I said, in the industry, you're constantly being bombarded by the effects that BIM can have on a project and the potential savings. So we wanted to see, even at the construction stage, if implementing it then would provide us with some savings. Just this little diagram here, you can see the traditional setup in a PAS 1192 project. Again, the EIR is outlined from the get-go by the client, but we weren't offered this, I suppose, so we had to sort of fill in that position and take that upon ourselves. This is just a quick slide of where the industry is at the moment. 2016, there's a bridge there between, well, I suppose that's being generous, between level 2 and level 3. But the main point to take away from this is that bridge that we're there at the moment is sort of reflects the initiative that we all have to take as, well, main contractors for ourselves, but also take on the onus so that we don't get left behind in this industry. As this progresses and progresses, the last thing we want to do is sort of fall short of the mark. So again, I'll show here the traditional workflow of a PAS 1192 project. You can see from the beginning, the client specifies exactly what they're looking for, and in turn that makes it a lot easier for us as a contractor to deliver what it is the client has specified. Because that wasn't the case in this particular project, we had to step into the shoes of the client, fill their role slightly, and develop an EIR ourselves. Now this obviously, as I said, was slightly problematic in that it required extra resources, extra time on our behalf, but it also allowed us to develop the EIR in such a way that benefited us, because we could then go to our subcontractors and say, this is exactly what we're looking for. Can you deliver it in this way? As well, we've also, as Matthew stated, generated a site model. This was used for site management, and he's going to discuss slightly how that was used day to day on site.
Yeah, bring it forward a little bit. The main issue, as I said, the main issue we had on site was the actual physical size of the site we had. So we've used this primarily to develop the model, one obviously for services. I should point out that the site was so congested that we actually had to take off a face of brick from our neighbours to get that extra 100 millimetres. That's how tight we're working to. So within the project itself, there is no room. We have to work to the dimensions given by the architect. So therefore, the coordination of services was absolutely critical. But within that, we also had so much temporary works in terms of scaffolding, tower crane bases was very important to us, and compound laydown areas. All of this had to be mapped out and planned and programmed beforehand, that we can actually prove to ourselves that what we were hoping to do would work. And that was also critical as we were going forward.
Thanks very much. So as you can see here, we began with 2D drawings. Now I suppose this is sort of counterproductive, but it's the way that a lot of projects are at the moment, where there are already existing 2D drawings, and it's somebody's responsibility then to develop a 3D model from these drawings. And that's exactly what we had to do here. Now, you could argue duplication of work, counterproductive, but we felt overall it was beneficial to ourselves in terms of coordination and delivering a final better product back to the client if we took on this responsibility. As I said, the level of development is such a large aspect of these models, and you need to be prudent in how much information goes into them. Otherwise, again, it's going to be counterproductive. You spend too much time and resources over developing a model. So because we had the flexibility, I suppose, to decide ourselves how much information we would need for ourselves and for the subcontractors, that we actually decided to sit on a level there of LOD 350. So again, that was an initial obstacle, and so how we overcame that really by selecting it ourselves, really. And another obstacle we had was getting the information from the offices. So obviously you can sit in the cabins and it's great to have your computer in front of you, but trying to get that information down to the lads on the ground can be quite difficult, and oftentimes you can lose information in that process. So we decided to avail of some of the free apps that are out at the moment that look at VR simulation. You can see the scan code there, and as I said, it's a free download you can get on your phones. It's compatible with both iOS and Android, and you simply just scan the barcode that's up on the screen at the moment. Now, you'll be able to do this later, but you will actually have to get the app. It's called QRVR, but it's quite interesting, and we think it's extremely beneficial for, say, lads down on site who are trying to install conduits or trays, runs, all that. If you are able to hold the phone up to a specific area in a room and say, look, this is overlapping this, is overlapping this, it's extremely beneficial for them instead of trying to articulate your point from back in the cabins. So we are working with Designer Group, actually we spoke earlier, who mentioned this project. And what they've done is develop their M&E systems directly from the architectural structure model that we developed from the 2D drawings. Again, just keeping that whole collaborative process moving, keeping it sort of streamlined and smooth, and eventually these models will go on directly to fabrication. So it's taken directly from the Revit model and feeds into the fabrication of the different elements. So just how the coordination was set up on the sides. Obviously there are multiple discipline models within this 3D platform, and Matthew here is just going to discuss a little bit about the images up at the top here and how they were used out on site.
As we were discussing earlier, coordination is really important on site, marrying permanent works with temporary works. And here you can see on the right hand side a photograph of the temporary props that we had to put in. And on the left-hand side is a model of the same. And what Marcus did was able to bring in the temporary work shown in the model into the permanent works. And when we started really analysing this, the complexity of what we had to do to build the structure and remove those props, the engineer was insisting that we actually had to go up to level 5, or if you will, we had 3 stories, a story above those props for the structure to be competent enough to remove them. From practical and program point of view, it really wasn't on. So we actually went back, discussed it with our subcontractors, and looked at other methodologies. So that was invaluable as a tool to understand what we actually had to do. So by using that, we were able to actually see what was coming up, analyze it, and we came up with alternatives. And in doing so, probably saved the region of a month, 5 weeks work in that. So that by itself was just an example of how we've been able to use BIM.
So as I said there earlier, there is a variety of different models in here. We were afforded a 3D point cloud scan from Murphy Surveys, which was extremely beneficial. We initially were working off old as-built drawings, and the accuracy of that was, I suppose, quite questionable. So being able to import a 3D point cloud, which we then actually drew over in Revit and could incorporate into the rest of the models, was extremely useful. This is probably familiar enough to, this process is familiar enough to a lot of you. Just sort of the check and review system in a common data environment. So the way we set it up was we used the clash detection tool to drive the coordination process. We did this generally once a week before meetings and pulled out any hard clashes that we felt were worth interrogating during the meeting. Anything that we couldn't resolve then in the meeting was RFI'd, was changed in the 2D drawings, which in turn was reflected back into the 3D model. And that went through then the whole check process, was drawn by the author, task team checked it, and then the project information manager approved it, updated to the common data environment, and the process was repeated like this week on week, just to hash out any issues that were identified. Thankfully, we were lucky enough in that every member of the project team was on board with this. They were capable, had the capacity and capabilities of working in Revit and Navisworks, and it just made the whole process a lot easier for us as a main contractor. So quickly then, some of the innovative measures on this project. I mentioned earlier some of the innovative measures on this project. As I mentioned before, the simulation, the VR simulation, and as well as that, this 3D modeling technology that we've just began within Stewart. This is extremely useful, we think, in articulating a point, as I said, from lads who are in the office to ground workers down on site. Being able to have a physical 3D thing that you can actually hold in your hand and say, look, this is where this is going, this is where this needs to be, is invaluable. And We recently got an in-house 3D printer, which is a plugin for Revit, which can take that model and then develop it into a 3D physical model for use on site. It's also a great visualization tool for the client as well, so we found that quite useful to date. Innovative measures again. So the current industry challenges at the moment, as was mentioned previously, is that it really comes from, the implementation of BIM really feeds from the top down, it comes from the client. So if the client doesn't specify it, someone needs to sort of take the reins and say, look, we can work to this standard, we have the capacity and capabilities and staff and training to do this, so you mightn't realise that you want BIM yet, or need BIM yet, but you actually do want it. It's just a term they're not familiar with as clients sometimes. I think that's most of ourselves on there. Sorry, again, this is an ongoing project, so it's quite difficult to quantify the overall savings.
We are.
More point. I'll wrap it up. So it is quite hard to quantify those savings, but we're confident that we will achieve our mark of 10%. This is reflected in a case study back in 1999, but you can look at that yourselves later on. So thanks very much for your time. I hope you enjoyed it. I'll take away from it.